There we go. I think we have audio. Sweet. All right, let's just try to see if things want to work again. I don't know what happened. OBS just like didn't want to work. So weird. But now we're back in action here. Just gonna quickly tweet out now that it actually works. Okay, so routings today. Routing. Routing. Okay, so let's make sure our server's up. Mix phx server. Man, OBS is so confusing sometimes. What are all these errors? Are we already going to get into a tangent? Maria X protocol failed to connect. I guess it's tangent time already. Let's figure out what this is. Why would we be having so many errors? Maria EX. It's interesting. Let me know if you can see the screen. I kind of changed around the layout a little bit, and let me know if it's all big enough and all that. I'll make this a little bigger so we can see it. Make this a little bigger so we can see it. All right, so first problem of the day is just starting up. So I restarted my computer and it was like, oh, we'll do updates now. Um, so I did updates and we restart the machine after actually I don't think I restarted the machine since I started streaming this stuff. So so actually this is probably something that like was prompted by the restart. So let's figure out what's going on. So we are using MySQL. That is something different. Maria EX. I kind of wonder if that's a MariaDB thing. This link gave me a hint. Okay. Let's see. Let's see. How do you achieve a connection to a remote database? I have MySQL hosted inside a Vagrant VM. I want to connect to Ecto, but it's resolved now. The information here helped. All right. So who gave an answer here? There's not a problem. I have a problem. We might just ignore this, but I do kind of wonder if maybe on my restart something wacky happened because and we can do a quick review of this, right? So the actual setup happens in the repository for Ecto, right? But where that actually happens is a great question. Let's see if we can find it. Get out of here. What is this? Get out of here. Hello, EX. Hello, application. Repo. So we're using the right adapter, which is MySQL. It's the name of our app. So that all should be fine. I mean, is it possible that MySQL isn't running? Okay, let's kill our server and look at that. MySQL. What is that? Improve services, start MySQL. Gosh, I don't even know how I have MySQL running. Hopefully we don't need MySQL today. We probably don't. We're gonna give this the old 2-minute test. My timer's already running, but I don't actually know when that started. My goal was to hit 30 minutes of actually doing stuff. So I gave myself 40 minutes to get past stuff like this. So that's fine. We'll just look at this for 1 minute and figure out if something's actually happening. Man, why is technology so hard? Of course, Postgres is actually running. This is probably the issue. I wonder why this is yellow. Let's see if this will let us like brew services, stop MariaDB, brew services, start MariaDB, brew services list. I mean, geez, I don't know. Curious if that does it. So now we do mix, Phoenix server. It's amazing how many times you have to type something over and over again to just commit it to memory. It's kind of interesting. Okay, I don't know. That's weird. I mean, it's pretty clear. Error connection refused. I bet I did something to MySQL locally, which is odd, but I don't think we'll need it today, so I'll fix that before the next stream. Yeah, so we're still loading here. That's fine. All right, so today's objective is to learn about routing as we continue through the Phoenix guides. This is more or less a test of the guides more than anything. So we did up and running. We got our app up and running. We added some pages last time and got through the basics of like views, controllers, templates, the basics of routers. And now we'll get into the actual details of routing today. Sound good? Good. I could do something else. I think the end goal, I was thinking about it, the end goal here is basically to learn enough. I mean, there's not that, I actually looked through all the documentation for Phoenix itself. There's not that much going on. Like, I mean, it's obviously, it can do a lot and it's non-trivial, but it's not like it's an endless an endless vat of documentation. So we could theoretically go through all these guides, skim through the rest of the documentation and know plenty to build something. So that's probably the direction that I would want to go to actually build something. But it's always nice to kind of go through the documentation and figure out what's going on. I don't usually do it like this, so this is kind of an experiment unto itself. All right, so routing. Routers are the main hubs of Phoenix applications. They match HTTP requests to controller actions, wire up real-time channel handlers, define series of pipeline transformations. Great. So this cool stuff. Like I've never really done sockets stuff with channels and all that, so that's kind of an interesting thing to dig at later. We've already looked at the router, so let's bring that back up just to refresh our brains. So we have our router. We're using the Hello Web router. We still don't really know what use means. We'll probably get to that eventually. I think it's just like using a library or like another module or something like that. That's kind of what I assume it is. Just making some coffee. All right. So it looks something like this, literally exactly what ours looks like. I guess we added a few extra routes inside the web scope. So, hey, look, it's going to tell us. The first line of this module, use Hello Web Router, simply makes the Phoenix router functions available in our particular router. So yeah, so that's just pulling in the router functions from the base, the base module inside of Phoenix. Scopes. So scopes are something that's kind of interesting. Scopes have their own section in this guide, so we won't spend time on scopes. No, that's fine. I suppose we'll get the scopes somewhere else. Wonder where they are. Hello Web do block. Hello Web. This one? Hello Web. But we won't spend time on the scope. Okay, so it's basically saying we're not gonna worry about this scope. So we're kind of just focusing our view inside of these calls here. The pipe through browser line will get a full treatment in the pipeline section. All you need to know is pipelines allow a set of middleware transformations to be applied to a set of routes. Okay. So middleware is this concept of a request comes in, a bunch of stuff kind of happens by default in between the request coming in and you handling it through your controller, which makes sense, right? You imagine back to that pipe, you have a request and it kind of goes through all these different actions or different functions through the pipe. So this is just another example of your request being piped through whatever browser is, which I'm guessing is this pipeline here, which we'll probably get to later. Inside the scope block, we have our first actual route. So this is what we're going to talk about in this today. Get slash, that's the root of the website. Tell it to go to the page controller, find the index action, right? Get is a Phoenix macro. Do we know what a macro is? I don't think we know what a macro is. I'm going to add it to the list here. I have an ongoing list of like things we need to learn. So let's add it to the list here, learning stream. We need to figure out what macros are. And I think that's an Elixir thing. Macros. We'll add that to the list. It expands out to define one clause of the match 5 function. 5 again is the arity of the function, the number of arguments I think it takes. Pretty sure. I wonder if this is better. Yep. It corresponds to the verb get. Similar macros. Yeah, this is pretty obvious. Basically, this is going to be an HTTP action, and this is going to be the actual URL that it's at. So this would be like a get to Phoenix, and then routing obviously is below that. Next 2 arguments of the controller and the action. That makes good sense. If this were the only route in the router file, the router module, it would look like this. Okay, so this is just kind of giving us a visual on what these methods actually do. So there's like a match, it matches on get and finds all this stuff. I wonder what this argument is for. The body of the match function sets up the connection and invokes the matched controller action. Yeah, makes sense. As we add routes, more clauses of the match function will be added to our router module. They're just like any other function. They will be tried in order from top. First clause will match the parameters given. Verb and path. Interesting. So basically it's doing like a little bit of a match going down the list here, trying to find one that matches whatever you pass into the actual router. All right. This means it is possible to create a route which will never match based on the HTTP verb in the path, regardless of the controller in action. If we do create an ambiguous route, the router will still compile, but we'll get a warning. So let's see this in action. Define a route at the bottom of this scope called get slash. So let's just throw it down here. I guess we can get slash, that's the root controller index. So these errors are the worst. Run mix compile, the root of your project. Okay. Mix compile. Mix is the tool that we can use to build things and do stuff. This clause cannot match because the previous clause at line 19 already matches. Yeah, that makes sense, right? Because it's already here. Cool. Okay, so let's get rid of this. We don't want that. Okay, that's neat. Examining routes. Phoenix provides a great tool for investigating the routes. Ooh, a mix task. Okay, so this is kind of the other piece of what mix does. Again, like rake with Ruby, is it provides you little scripts and stuff to do useful things. So for example, we could do phx, so mix. We always use the mix. I don't know what that's called. Is that like a class? It's not a class, obviously. It's I guess it's a module or something like that. Program. I have no idea. Mix Phoenix routes. Look at that. So now we get a list of all the routes that exist for the app. That's cool. Go to the root of a newly generated Phoenix application and run mix Phoenix routes. Yep, we did that. You should see something like this, which we see. The output tells us all of the things be handled by the index action right here. Yep, that makes sense. Page path is an example of Phoenix called a path helper, right? So if we want to just jump to this path in the app, we can invoke the page path function probably. We'll talk about those very soon. Can't wait. Very excited. The router supports other macros. We got to know what a macro. We got to go on a tangent. Elixir macro. We need to know what a macro is. We can't go this long. Even though Elixir attempts its best to provide a safe environment for macros, the major responsibility of writing clean code with macros falls on the developers. Macros are harder to write than ordinary functions and are considered to be bad style when you use them when they're not necessary. So write them responsibly. I love that there's a foreword here. It's amazing. It already writes. So Elixir provides mechanisms to write your everyday code in a simple and readable fashion using data structures and functions. It should only be used as a last resort. Remember, explicit is better than implicit. I agree. Clear code is better than concise code. Also agree. Man, you get me, Elixir. All right. So they're defined here. Oh man, how long is this? Are we gonna go on this much of a tangent? Let's just get the gist. So unless does the opposite of if. Def module unless, function unless, def macro, macro unless. Oh, I love that there's a. What is this? I'm totally getting sidetracked. Oh my God, there's a documentary. We gotta put this on the list. We gotta take this. We gotta see that at some point. That's hilarious. Okay, back to this. Okay, this is great. I think macros are gonna be like little like um I mean like def for example, right? Like we're looking at we're looking at get. I'm sorry, not def. Get. And that isn't necessary. It's like a function that doesn't have um it's like a function that doesn't have parentheses, but I don't know why that would matter. Maybe that doesn't matter in Elixir. What is an Elixir macro? I just want like the one line definition file. Hacker noon. Oh, is it like metaprogramming stuff? Code that writes code. Yeah, so metaprogramming is this idea that you can kind of write code that generates code that would be executed. Um, so maybe that's all that is. So here is an example. Let's define our first macro. Nice print. Accepts some arguments. Does some stuff. So then you require the macro nice print some arguments and it just prints it. Okay, so that's why there's a disclaimer in the documentation because they're basically saying, look, you can use functions and you don't need macros. You can just use functions for most stuff. So just beware. Okay, that's fine. That makes good sense, I think. So we'll just know that macros are another way to kind of define functionality. We don't understand the difference yet. We'll have to go back to Elixir and learn that later. So let's see. Right. So it supports other macros, right? Functions that do things. We don't know what the difference is, but let's pretend we know. Besides get, post, and put, the most important among them is resources. So this is a Rails. This is very similar to something Rails does, where resources will auto magically give you all of the HTTP verbs per an endpoint. So let's add one. Resources, right? So not get, not put, resources, users, user controller. Okay. For this purpose, doesn't matter if we actually have a user controller. Go to the root of your project and do Phoenix, mix, phx routes. Compiles our files and look at all these user things. Right? So resources gives us like 4 kinds of gets. So a list, an edit, a new, and a fetch for that ID. It gives us a post to that so we can create new ones, and a patch and a put so we can edit them, and a delete. That's pretty cool. I'm going to skip all this because this is old news for me, as much as I'd love to go over it. We could be selective, so that's always helpful. So if you only want to return certain routes, you can say only index. Let's do mixed routes again. Now we only get the index action, which would be a list. Very cool. And then you can say accept. That's cool. The Phoenix router resources for function describes additional options for customizing routes. So as a little tangent here, we can go over here and we can see a method that, and it is for arity. That's the 4 things it accepts. path, the controller, options, and list. So that's an example. This would be an example of options was only or except. The name of the parameter, that's interesting. Prefix, right? Configure. What was the other argument here? List. What does list do? Singleton true. When resources need to be looked up without referencing an ID because it only contains a single entry to a given thing, the singleton option can be used. Oh, cool. So basically that would give you back a list of all of the items, so you don't need to pass an ID, I guess? That's kind of interesting. When a resource needs to be looked up without referencing an ID because it only contains a single entry in the given context, the singleton option can be used to generate a set of routes. In the given context. Huh. Well, we'll dig into that later. Okay, forward. The forward macro can be used to send all requests that start with a particular path to a particular plug. Or plugs to refresh ourselves because terminology is hard to remember. Composable modules between applications, right? Let's say we have a part of our system that's responsible, it can even be separate app or library, for running jobs in the background. Pretty common. It can have its own web interface for checking the status of jobs. We can forward to this admin interface. Oh, interesting. Beep. Forward jobs to background job dot plug. Wow, so you can completely redirect the request to a whole different app. This means all routes starting with jobs will be sent to this module. We can even use the forward for macro in a pipeline if we wanted to ensure that the user was authenticated in an administrator. In order to see the jobs page, we could use the following in the router. Okay, so we're piping through. Remember, we didn't want to talk about pipe through, but it looks like they're doing 2 pipes in the scope before forwarding off. Does that make sense? This means the plugs in the authenticate user and ensure admin pipelines will be called before the background plug, allowing them to send the appropriate response and call halt. That's pretty neat. The OPTS that are passed into init1 callback of plug can be passed as a third argument. For example, maybe the background job page lets you see the name of the application to be displayed on the page. This could be passed with name. So if we go look at forward, so this is just giving us examples on how forward works. There's an interesting thing here that they do. That's how I think how you do default arguments. So this is saying plug options by default is an empty list, right? Elixir list. It's not an array. It's a list, I think. Just make sure that's right. Yep, it's a list. Same here. Router options by default is an empty list. So router options. Let's see. Okay. Where were we here? Fourth is router options. The options are outlined in Phoenix Scope 2. It's interesting that they're in the Phoenix Scope and not the forward method. Wonder why. List. Oh, is it all these? Got it. Signs. The map updated to merge in the connection when a route matches. Okay, that's cool. Although it's possible to forward to any module plug, it's not advised to forward to another endpoint. This is because plugs defined by your app and forwarded in the forward endpoint would be invoked twice, which leads to errors. Okay. Write an actual job worker is beyond the scope of this guide. However, for convenience, to allow you to test the code above, here's an implementation of background job plug. Blah, 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 blah. Now we don't need to do that. Plug on. The whole plug thing is kind of interesting. Oh, that's interesting. That's the next item on the list. Because I was like, that feels like the next logical thing, given how much they're talking about it. But I don't know anything about it. It looks pretty simple, though. Plug match. Background job router. Use the plug router. Plugs is something we're going to have to get to next. Plug match, plug dispatch. Send a response. Okay. Path helper are function which, okay, so yeah, so we went over this earlier. So path functions are functions which are dynamically defined on the router helpers module for an individual application. For us, that is hello web, router, helpers. Do we have that here? I think we do. Helpers. Oh, we do. And that's the lib. We don't want that. Their names are derived from the controller used in the route definition. Our controller is page controller, and the page path is a function which returns the path to the root of our application. Okay, that's a mouthful. I was just gonna say, like, what? What? I don't understand. That's okay. Let's see in action. Run IEX. Okay, cool. Let's do a thing. IEX/s mix. So we're gonna run IEX is the interactive Elixir -s. I think is like a server. I don't know why mix is at the end of that one. God, this error is the worst. We're gonna have to fix that. All right, so let's do this. Hello web dot router dot helpers dot page path. Oh my god, I can't do it. I can't do it. We're gonna have to fix that. What is going on with this? MariaDB. MySQL. Oops, MySQL. Can't read the directory. No such file or directory. What happened? Program aborted. Is there like a configure in here that I can just comment this out for a second? Config hello repos. Let's just try that for a second. I just didn't like that. It seems like that would be the place to do it though. Comment that out. Syntax error, unexpected comma, parentheses required to solve the ambiguity in config 14. Oh, maybe I just need to. That's interesting. I wonder why that's done like that. Maybe this is all we need to do. Nope. Failed to connect. Man. Okay. Secret keys, render errors, pub sub, logger, config the library, application.ex, start. There we go. Start the ecto repo. All right. What if we did that? It's stuff like this that helps you learn how the thing works, usually, anyways. Silly little errors. Yeah. So in the actual start function, one of the steps is to start the repo, the ecto repo. So we stop that. It stops failing to connect, right? That's kind of neat. All right, back to a regular scheduled issue. How much time do we have left? 7 minutes. All right, we're gonna have to extend. We're gonna have to extend just a little. Hello web. That's our app. Our app for the web app, I guess. Invoke the router module. Invoke the helpers module. Call the page path for the hello web endpoint index. Look at that. This is significant because we can use a page path function in a template to link to the root of our application. We can then use the helper in our templates, right? So that's kind of neat. So let's do this. Can we edit the thing? We should edit the thing. Hello web. Oops. Controllers, templates. In our templates, hello index from planet Eeks. So we can drop a link in there. The href is going to be, this is interpolating the Elixir, calling the routes module, the page path function, passing in a connection, passing in which action we want to link to. Let me say to the welcome page. Yeah, we can do that. I'm sure this tutorial is about to do that for us, but oh, hang on, let me start the server again. Actually, let's just follow the tutorial. I bet it's about to tell us to do this. Get out of here. The reason we can use routes page path instead of the full. Okay, no. Hang on. You're getting ahead of the game here. Let's start up the server. Let's just look at that because I like to see it. Make sure I understand what's working there. If it's working there, or what's here for life. Hello world from Planet Eeks. Index. That, let me see. That'll be on /hello, right? Because templates hello. Here we go to the welcome page. Look at that. It's amazing. Okay, so now let's get your explanation. The reason we can use routes.pagepath, right? Because routes was a module, pagepath is the function, but look at how far down this actually lives inside of hello web router helpers. Because hello web router helpers is alias routes by default in the view definition. lib hello web.ex. Is that just something that like is part of the deal here? There it is, webex. It's just so small. So we have our controller. We're going to ignore that. We have our view. This is actually kind of interesting. We have our router, channel, def macro. Hey, there's a macro. So we call this thing hello web, and it has 4 functions. Controller, and I'm sure that's actually, interestingly, that's not using anything by default. So that's just hello web. Controller, view, router, channel. And this is saying in the definition of the view, what is quote? We don't know what quote is. It's saying use Phoenix view. And right here, it's aliasing hello web router helpers as routes. That's cool. So by default, hello web, the application hello web is aliasing this chain of kind of modules together as routes. And that's why we can say routes page path. We can of course use this if we wanted to, but the convention is used to the convention is to use the alias version for conciseness. And then outside of that, you'd have to define your own aliases like they did. Which makes sense. This pays off tremendously if we should ever have to change the path on our route. Since the path helpers are built dynamically from the routes, any calls to page path on our template will still work. So page path, so let's just confirm we understand that, which I think we do, but it's worth looking at. So the page path, what about hello path? What about hello path? So if I did hello path and I say go to the index, right? Because that's going to say this, I guess, and go to the index. Is that right? So if I go to hello, and I say, all right, yeah, but obviously that's not going to go anywhere though, because let's do that on the home page or on the whatever page, the index page. Okay, right? So we have the root. It goes to the page controller. The page controller has a template called page index.html, right? And if we go to the home page, we get rid of that there. Say we wanted to have a hello link under Corey was here. We do this. Boom. We do hyperlink. We interpolate some Elixir. We say the routes module, and we want the hello path, and we want to go to the index method. And this will say, now, this obviously won't, to the hello page. This actually won't do anything particularly useful. Oh, yeah, it'll actually render that because we do have an index under hello. Right. Okay. Right on. So that's the basics there. More on path helpers. We're going over the time limit. We had a minute, but we're going over today, just a little. When we ran the Phoenix routes test for our other resource, it listed user path as a path helper function for each line of output. Alias hello web endpoint routes user path. What about query strings? That's a great question. So we ran our Phoenix routes test for our user resource. It listed the user path as the path helper function for each line of output. User path endpoint. Right. What What about path with query strings? So the show endpoint passing in 17. This allows you to pass in those query strings. Okay. What if we need a full URL instead of a path? Just replace underscore path with underscore URL. Right. Okay, that makes sense. Right. All right. So let's get out of here. Let's go back to our IEXS mix. We'll say. Now this is cool. Notice what they did. Alias, hello web, router, helpers as routes. That's replicating what happens inside of our view, right? So now if we say route, that works. Alias hello web dot endpoint. Now I think if you don't pass it anything, it automatically just does endpoint. Yeah, it just does whatever the last in the chain is. So if I do routes dot user URL endpoint, which is our endpoint thingy, and we do index, so that's saying what's the endpoint for the index action in the user route. User URL endpoint index routes user URL. Function hello web router helpers user URL is undefined or private. Okay, what do we do wrong? Routes dot user path for endpoint. Oh, you know what? Let's do hello. Let's do hello. So hello path. We deleted the user route. Hello path. Hello path. Endpoint index. That gives us the full path. And if we did URL, or that gives us the path, this gives us the full URL. So if we wanted to say admin true, active false, that would give us everything. Whereas if we did the path for that, I don't even know. I guess it would just cut it off. Probably. Oh, it gives us everything. That's crazy. It just accepts like an arbitrary list there. The URL functions will get your host, port, proxy, and SSL info needed to construct the URL. You can look, let's see. For now, you can look here to get those values. That's fine. Whenever you can, pass a connection in place of the endpoint. I don't think we don't have a connection though, obviously, right? Not here. Yeah. Nope. All right. Neat. How much more do we have here? I think we're just going to try to rip through the rest of this. We should just get this done today. We'll never get to build anything if we don't finish this stuff. It's also possible to nest resources in a Phoenix router. Let's say we have a post resource which has a minimum relationship with users, right? The user has many posts. Okay, we can represent that by adding nesting. All right, so I should probably just add back my resources users to the user controller, do, and we're nesting resources similarly, posts, post controller. Okay. So that's going to create like /users1/posts, which you see here. It gives us all this junk, which is awesome. That's very handy. And we can get the post path, the user post path. So we can say user, instead of just user path or user URL, user post path, and that'll give us the whole path. The same goes for the arguments. Okay, scoped routes. Scopes are a way to group routes under a common path prefix in scoped set of plug middleware. So this is good. This is the good stuff. This is the good stuff, right? So this is where we see our scope here. We might want to do this for admin functionality APIs and especially for versioned APIs. Let's say that we have a user-generated review on a site. Those reviews first need to be approved by an admin. The semantics of those resources are quite different, and they might not share the same controller. Scopes enable us to segregate those routes. The path to user-facing reviews would look something like this, okay? So that's basically just a regular reviews resource, right? So if we wanted to replicate what they're asking for here to kind of show that we know what we're talking about, I think. Reviews, the review controller, right? We can do IEX exit, Control C. We'll do, let's try to remember what it is. Mix Phoenix routes. Right, so now we have our review stuff here. The admin paths can be prefixed with admin. You can accomplish this with a scoped route that sets the path option to admin, like this one. Let's not nest this scope inside of any other scopes. Like the scope / hello web do one provided for us. I mean, that's what my first thought was going to be, but I guess, oh, I think it's just saying, like, you can just put it out here, maybe. So scope, the admin prefix, do, pipe through, right? I'm going to pipe it through the browser. We'll have to figure out where that lives at some point. Then we're going to say we have resources, reviews, and that goes to the hello web admin review controller. Now that's interesting because I wonder where this admin piece lives. I guess they'll tell us later, probably. Note that the way this scope is currently defined, we need to fully qualify our controller name. We'll fix that in a minute. Yep, see? Running mix Phoenix routes. Okay, let's do that. Boom. Now we have admin reviews. Look at that. It's amazing. Running mix Phoenix routes again, in addition to the previous set of routes, we'll get the following. This looks good, but there's a problem. Remember that we wanted both user-facing review routes as well as admin ones. Now, if we include the user-facing routes in the router, it look like this. That's actually what we did originally, right? But we lose reviews. We lost reviews. Or did we? Did I get rid of it? I got it right here. Wait. Oh, I did get rid of it. Hang on. Resources, reviews, review controller. Okay, we have both. Nice. Now this is interesting. We're getting the same one, right? So to get to the list, you get review path, but here review path is the same. We can fix this problem by adding an as admin option to our admin scope. Do, it's before the do, right? As admin. That's a Adam. As scope as admin. What's that do? What's that do? Oh, it just prepends the whole thing. Interesting. Path helpers now return what we want. As admin. So the as argument to the scope. So if we look at Phoenix scope, let's go here. Let's find the scope method. Functions, scope, accepts a list. A string or atom Clayton had to go to stand up. I guess that's a problem with that's kind of the issue with streaming during the day. So a string or atom containing the named helper scope. I see. So you're creating a scope. The as literally says what scope am I within? Okay, that makes sense. And now we get what we want. What if we had a number of resources that were all handled by admins? We could put all of them inside the scope like this. And then all the paths would be what you'd expect. This is great, exactly what we want, but we can make it even better. Notice that for each resource, we need to fully qualify the controller name by prefixing hello web admin here. That's tedious and error prone. Assuming the name of each controller begins with hello web admin, we can add a hello web admin option to our scope declaration just after the scope path. And then all of our, okay, that's nice. That's actually really nice. So we do it right here. And what's cool about this is hello web admin. Hello web admin. And then if we rerun, does that work? It does. It does. Now what's interesting is we go back to this and we kind of look at our scope. There's 3 scope functions. They each accept a different arity. So this would be an example of the 3 one. where it accepts the options second. The macro. I'm kind of curious. Options. Oh no. This is the one we've been using. We've been using 3 all along because you have a path, admin. You have a path as the first argument, admin. The second argument is your options. And your third argument is the list. But this is what's interesting because this is actually maybe this is actually the 2 because I think that's converting. I'm kind of surprised that works. Because like, what's the 2? The 2 is the options in the list. I don't think we're passing a list. Path as alias for just the list. 1, 2. Oh, here's your 4. Scope path 1, alias 2. Guess I don't really know what the list means. Should probably figure that out at some point. Interesting. Oh well, moving on. This doesn't just apply to nested routes. We can even nest all the routes for our application inside a scope that simply has an alias for the name of our app, and eliminate the duplication of our application name and our controller names. Phoenix already does this for us, and it generated a router for a new application. Notice here all of hello web in the scope declaration. Right, so notice here the use of hello web in the scope declaration. Right here. Oh, that's cool. I see. So this thing here, hello web, is an alternative to saying hello web dot page controller. So we're already aliasing the scope, which is no different than what we're doing down here. Yep, that makes sense. So nested scopes are generally discouraged because it can sometimes make our code confusing. That said, suppose we had a versioned API with resources defined for images, reviews, and users. I see. So you'd have an API /API, and then you have a /v1 scope, and then you could have a different controller for each version, which makes sense. Interestingly, we can use multiple scopes with the same path as long as we are careful not to duplicate them. The router is perfectly fine with 2 scopes defined for the same path. So /hello web, another web app, they're both scoped to /, but the /users and / interesting. So you can basically wrap your routes around different controllers. Okay, that's neat. But if you put this posts up here, it would blow up. All right. We've come quite a long way in this guide without talking about one of the first lines we saw in the router, pipe through browser. It's time to fix that. All right. We describe plugs as being stacked and executable in a predetermined order, like a pipeline. Now we're going to take a closer look at how these work. Yeah, because this is a good question. Like, what is this? What is this doing? They allow us to customize behaviors and transformations related to a request. These are all the default ones. A newly generated Phoenix app defines 2 pipelines called browser and API. We'll get into those in a minute, but first let's talk about the plug stack and the endpoint plugs, okay? Oh, interesting. I didn't even see this. So there's 2 plugs here. One is API and one's browser. One is API and one is browser. So this accepts HTML. It gets a session, it gets some Flash stuff, protects from forgery, secure browser headers. This one just accepts JSON. So this is just for rendering JSON. The endpoint plugs. Static, code reloader, request ID logger, parser, method override, head, session, router. The endpoint plugs. Did I see these anywhere? Pipe through browser. Right, so this request is piping through this set of plugs. Endpoints organize all plugs common to every. Is this an endpoint though? This isn't an endpoint. What's an endpoint? Right here, endpoint. Are endpoints later? Yeah, endpoint. I'm going to ignore endpoints. They're later. Endpoints organize all plugs common to every request and apply them before dispatching into the router. With their underlying browser API and custom pipelines, this is default endpoint plugs do quite a lot of work. Okay, so this is all the stuff that happens very like when the request comes in. These are all the things that happen by default. Static serve static assets because they're not logged, so they come before the logger. Oh, I see what this is saying. So I bet if we went into this, these are endpoint.ex. So we can go look at the Phoenix endpoint, and I bet it defines the plugs in here somewhere. Maybe pipeline. No, no, it doesn't. Everything in my life's a lie. What's it called? Pipeline, pipe through, pipe through. Nope. I'm sure it's somewhere in here. What the endpoint? I guess the endpoint class, like static. That's okay. We don't need to. Oh no, it is. It is here. Require logger. So those are all sub thingies. That's fine. So these are all the things. Get out of here. I'm not printing anything. So these are all the things that happen before the request happens. So code reloader, a plug that enables code reloading for all the entries in the web directory. Right. So there's some code reload. So like if we were to look at one of these, a plug and module to handle automatic code reloading. For each request, it checks if anything, any module is previously compiled requires they require recompilation. Then calls mix compile in the web directory to avoid risk. So that's really cool. So this is the thing that just watches to make sure that the thing gets reloaded. That's how that auto reload stuff works. Request ID generates a unique request ID. Logger logs any requests. Parses the request body. Uses URL encoded by default. Multipart in JSON. With JSON. JSON's the JSON library for Elixir, I think. The request body is left untouched, but the request content type cannot be parsed. Okay. So this is how HTTP requests into Phoenix actually become parsed. Converts the request method to put, patch, delete, post. So method override. The plug provides the request. The plug overrides the request's post method, with the method defined in the method request parameter. Interesting. So someone makes a request with the method parameter. It converts the request actually into a put, patch, or delete. That's kind of neat. So that's so you can make a post request with the type of method. I don't know why you wouldn't just make an actual delete or put request, but maybe that's not how everybody's systems work. I don't know. That's how I've always done it, but converts the head request to get requests and strips the body. Let's see. Plug to convert the head requests to get requests. Right, so you can make an actual head request. Interesting. Okay. A plug that sets up the session management. Note that fetch session 2 must still be explicitly called before using the session, as the plug just sets up how the session is fetched. And of course, router, which plugs a router into the request cycle. So these are all the things that happen before it even gets to your router to actually do something. Okay, then we have some browser and API pipelines. Phoenix defines two other pipelines by default, browser and API. The router will invoke these after it matches a route, assuming that we have called pipe through them in the closing it right here, pipe through browser. Browser pipeline prepares a route which renders requests for a browser API for producing data for an API. So this is cool. So this is actually telling us what each one does. It defines a request format which will be accepted. It fetches the session. Choose any flash messages, which must be set. Flash is like when it says like successfully deleted a thing. As well as protect from forgery. Put secure browser headers to protect from cross-site scripting. That's great. And obviously we only accept JSON in the API request. So if we wanted to say like only accept a specific type of JSON, we could put a plug into the pipeline to say, look at the JSON that comes in, make sure it's the correct format or whatever, and we can throw them back an error if it didn't. The router invokes a pipeline on a route defined within a scope. If no scope is defined, the router will invoke the pipeline on all routes. Although the use of nested scopes, yeah, we talked about that. Yep, so you can nest pipe through, which is neat. Those are a lot of words bunched up together. Let's take a look at some examples. It actually makes kind of perfect sense to me, to be completely honest. So when the server accepts the request will always first pass through the plug in our endpoint, after which we'll attempt to match on the verb. Let's say it matches a get to slash. The router will first pipe that request in the browser pipeline because of slash, because this matches, right? It'll fetch all the stuff that happens in the browser before it dispatches to the page controller index, which is what happens here. If the request matches any of the routes defined by resources to macro, the router will pipe it through the API pipeline. So it actually matches the route first and then pipes it through. If we know that our application only renders views for the browser, we can simplify our router quite a bit by removing API stuff. Right. So this is basically saying, like, you don't actually need this. And the scopes too. Like these. But we know we're probably only gonna render an API potentially. Or we'll probably end up rendering both, I'm thinking. Whenever we actually build the thing we're gonna build. So if we needed to go through the browser and more custom pipelines, we'll pipe through a list of pipelines. Right? Pipe through browser, review checks, other great stuff. So you can actually pipe through all of these things. That's actually amazing. So you could have multiple pipelines of plugs, and you can pipe through them on every request. Review checks. Okay. Phoenix allows us to create our own custom pipelines anywhere in the router. To do so, we'll call pipeline to macro, which accepts, the name, I guess, an atom for a name, and a block with all the plugs in it. Review checks. All right, here's the end. Channels. Channels are very exciting. I agree. Channels handle incoming and outgoing messages broadcast over a socket. Socket enables that two-way communication, which is really neat. Channel routes then need to match requests by socket and topic in order to dispatch the correct channel. We mount the socket handlers in our endpoint. Socket handlers take care of authentication callbacks. So let's say we have our endpoint, right? That's where we're at. So we handle sockets in our endpoint. So is endpoint kind of the same as router? It kind of seems like that. Socket. This is a user socket. WebSocket true, long pole false. By default, Phoenix supports both WebSockets and long pole when invoking the socket method, your endpoint. Here we're specifying that the incoming socket connections can be made via WebSocket connection. What is long pole? Long pole sockets. Polling. Delay is predefined. Hit it, wait. Hit it, wait. New data is available. Hit it, wait for the response. New data is available. So polling is when you hit it and return. Hit it and return. Hit it and return. So you're just polling the server, looking for changes. I don't understand how long polling would work. So you poll, and you poll again, but you wait before sending. And obviously, WebSockets actually comes down. WebSockets tells the client when something happens. Short polling is an Ajax-based timer that calls it fixed delays, whereas long polling is based on Comet, i.e. server will send data to the client when the server happens. What is Comet? Both have pros and cons. Okay, sure. Comet is a web application in which a long-held HTTP request allows the server to push data down to the browser without the browser explicitly requesting it. Oh, that's interesting. So it opens a connection and just holds it? Comet is an umbrella term encompassing multiple techniques for achieving the interaction. All the methods rely on a feature included in default browsers such as JavaScript, rather than non-default plugins. Comet approach differs from the original model of the web in which browser requests a request completed at a time. Huh. Ajax push, reverse Ajax, two-way web, streaming, HTTP server push. No kidding. I never even heard of that. Okay. So that's long polling. Learned something new. Only took an hour to get there. I'm curious what the timer did. Did it go negative? Did it restart? It must have restarted. That's crazy. Just some crappy JavaScript thing. Okay, so back to this. Let's see. So yeah, so we're turning off long polling, enabling WebSockets. Next, we need to open our user socket. So let's see. Plug. This is doing a lot of jazz. A lot of jazz going on here. But I think we're going to take it one at a time here. So we had to open our user socket file, which is what this socket's pointing to. That's a channel. It's in the channels directory. By default, it's blah, blah, blah. Next, we need to open this and use the channel3 macro to define our channel routes. Our channels right here, maybe? Channel. We have a channel module called room channel and a topic called rooms star. The code is straightforward. Pipe all of our rooms to the room channel. Topics are just string identifiers. The form we're using here is a convention which allows us to define topics and subtopics in the same string. The star is a wildcard character which allows us to match on any subtopic. So room's lobby, room's kitchen would all match. So in the rooms channel, we're matching any. This must be the topic. This must be the topic. Any subtopic, yeah. So rooms is the topic. Channel name. But the thing is, like, why does the channel have a topic? Like, isn't that just a channel name? I guess they call that a topic. That's fine. That seems reasonable enough. Each socket can handle multiple requests from multiple channels. Rooms, foods, channel, food channel. Multiple channels, user socket. Okay. Cool. We can mount multiple socket handlers in our endpoint. Admin socket, user socket. You know, sockets are brand new to me, and I think they're really neat. I bet if we got to the point where we were building something with sockets, it would be a lot of fun. Like a chat, like a Slack clone or something. I bet that would be really neat. Summary. Here we go, the big finale. Routing is a big topic, and we've covered a lot of ground here. The important points to take away from this guide are routes which would begin. So let's go back to where we started here. Routes which would begin with HTTP verb name expand to a single clause of the match function. Right? That's what this is. Routes which begin with resources span to 8 clauses. Right? So we saw that we get all those routes when we use resources. You can use the only and the except. Right? It makes a lot of sense to me. I guess I deleted that example. Any of the routes may be nested. We saw that with admin reviews. They may be scoped within a path. We saw that with admin. And we also saw that with our default scope. Using as option in a scope can reduce duplication, right? So as admin, so now we have like admin, this gives us admin reviews, path, admin reviews, edit path, etc., etc. Using the helper option for scoped routes eliminates unreachable paths. Using the helper option for scoped routes What, did I miss that? The helper option. Helper. Oh. Yes. Right. I think it just means the path helpers. Right, because you reduce your if you're always using paths, you'll never link to a URL that doesn't exist because the path will that using path the path function will probably not compile. It'll say that doesn't actually exist. Wow, we did it. We did it. Okay, that's routing in Phoenix. I think it's kind of a slog to go through documentation, honestly, but like there's so much here. Like how could you possibly build an app without at least understanding most of the stuff? If nothing else, reviewing it, which is essentially what we're doing. Curious how long that one must have been one of the longer ones. Yeah, that was. Plugs, endpoint. I mean, we're gonna rip through the rest of this. So here we go. That's routing in Phoenix. Pretty straightforward. I think Phoenix figured out how to do this in a really nice way. I mean, there's not a lot there that you have to reason about, and it's all pretty straightforward, and it seems pretty well thought out. So I'm pretty excited to dig into it a bit. All right, tomorrow, same place, same time. Boy, we went 40, we went over an hour here. Hey, you got to put in the hours. You know what I mean? Got to put in the hours. All right, folks. Till tomorrow.